Welcome back to another Daishinfinity video. In this video, we're going to talk about set theory called equivalence classes, saying that if we have a set A, that the set A is a subset of A. And the second one says that if we have a subset A in B and a subset B in A, that A should be B. And the third one is if A is a subset of B and if B is a subset of C, then A is a subset of C. Okay, let's just dive right in, since it's not that hard to just show the proof. So the first one is also called reflexivity. So if we have a set A, which is a subset of A, it will mean that for all x which is in A, that x is in A. Okay. So you see, if x is in A, x is in A. So this is obviously true. So this is a true statement. So we can say we have shown that A is a subset of A. The second one is A is a subset of B, and B is a subset of A, which will imply that A is equal to B. Now this is a bit tricky, but it's not that difficult if you argue with x. So let's say x is in A. If x is in A, we can see from this first expression that for all x in A, that x is also in B. Okay? And we can also say from B is a subset of A that for all x that is in B, that x is also in A. Now this would mean that A will imply B, since if we go from A, when x is in A, it will imply that x is in B. And if we have x is in B, so B, then x is also in A. So B will imply A, logically saying. And I have another video talking about equivalences. We have proven that A implies B and B implies A is actually equivalent to saying that A is equal to B, or A is equivalent to B. Now, equivalent to B is just same as saying A, that the set A is just the same thing as saying it's a set B. So we have proven the second formula, which is the symmetry formula of the set theory. Now the third formula is the transitivity, which states that if A is a subset of B and B is a subset of C, then it will imply that A is a subset of C. Okay, so how can we argue about this? How can we prove this formula? Now we know that we can prove everything with x's. So for all x, element A, which will imply that x is in B. Okay, this is the first statement. And the second statement says that for all x in B, x is also in C. So B is a subset of C. Now, how can we imply that A is a subset of C? Well, we can prove by contradiction, which is also common, but I'm just going to prove it directly. Now, if A is if x is in A and it implies that x is in B, then we can say that A implies B. And if x is in B, that implies that x is in C, then we can say that B implies C. And we can logically say that if A implies B and B implies C, which is just like having a function and having another function and having another function. Okay? Let's say H is like F and G combined. Then it's the same thing as going from F to H or F to F combined with G. So this is just like some logic stuff. If you want to really prove why this works, then I would have to make another video. Please write it in the comments if I have to, so that I know you guys don't really understand why this is equal to, like, equivalent to saying that it implies that it's A implies C. But yeah, normally we can say here that A implies C. Since obviously if X is in A, X is in B. And if X in B, X is in C, then obviously X should also be in C when X is in A, you know? So it's somehow logical. I hope you guys enjoyed this video. Please like and subscribe. And if you have any questions, please comment, and we'll see us in the next Daishinfinity video. See ya.